All right, hey guys, I'm making this before the test quiz thing that we have tomorrow. It's going to be over these exponential and logarithmic problems. As you can see on this worksheet here that we've done, I'm going to go ahead and do all these problems for you. Please feel free to skip ahead in the video. I know this might be pretty long, but feel free, like I said, to skip ahead in the video to try and find the problem that you want to look at if you got stuck on any. Or just watch the whole thing if you want to try and become a master at it. But anyway, I figured I'll go over these. And I might even go over some of the exit slip problems as well from the exit slip I gave today. But what I'm going to do is I'm going to go to my sketchpad here, and I'm just going to write down the problems on this blank canvas. All right. But if you have the worksheet with you, of course, you can follow along with those problems. So the first problem is 5 to the 2x power equals 20. So for the first 6 problems, they're all exponential problems. So they're all going to follow the same 3 steps. Step 1 is to put log on both sides. So we're going to keep this equation exactly the same, but we're going to put log 5 to the 2x power and log 20. So it's still 5 to 2x power equals 20, but it's the log of both of them. And then we're going to use that, use those logarithms, and use the property to move, this is step 2, move my exponents to the front of the logs. So there's only one exponent here, it's a 2x. We're going to move it to the front of its logarithm. This will become 2x times log 5 equal to log 20. And then step 3 is to divide logs. So notice the x is on the left side, so I want to try and cancel out everything from the left side as I can. So what I'm going to do is I'm going to divide both sides by the log 5, because what will happen is it'll cancel out on the left, just leaving me with 2x. And then log 20 divided by log 5 is a decimal, but if we round it, it's 1.86. And then just divide by 2 here, and we get x equal to 0.93, or roughly equal to. It's a rounded number, but roughly. Basically, everything above that line here was these 3 steps. These 3 steps are extremely repetitive for all these problems. Everything below that line is basically a normal math equation, right? And hopefully you can solve a normal math equation. So let's go and let's try number 2. So number 2 is 12 to the 2x minus 8 equal to 15. Same 3 steps. We're going to start by putting a log on both sides. And then step 2, we're moving the exponent, which is a pretty big exponent, but we're moving all of it, 2x minus 8, moving it to the front of our log 12. And then again, since our x is on the left side, we're going to want to divide by the log 12 so that we can cancel it out. So we end up having 2x minus 8 equal to log 15 divided by log 12, which I forget. So give me a second. Try to type this in my calculator real quick. Log 15, close the parenthesis, divided by log 12. Equals 1.09 if we round it, 1.09. So again, you're just solving this normal math equation, right? Add 8 to both sides. We're going to have 2x equal to 9.09. And then divide by 2, we get x equal to about 4.54. Depends on how you're rounding it, but about that. Okay. Again, the top of this line is those 3 steps. Log both sides, move the exponent to the front, divide by your log. And at this point, once we're here, it's just a normal math equation. So number 3, again, I'm trying to move kind of quickly here because I know we talked about this already mostly in class, but this is mostly for anybody who's absent. And we worked on it Friday too, but number 3, again, same 3 steps. We're going to put log on both sides. So we got log 2 to the x plus 6 power equals log 4. Step 2, move the x plus 6 to the front. Get x plus 6 up there. Log 2 equals log 4. And then, of course, divide by log 2, since that's on the side with x. We get x plus 6 equal to 2. And so when we subtract 6, we get x equals to negative 4. And that's totally cool. We can have a negative number as x. That's fine. Number 4, we have 16. 16 to the 5x power equals 64 to the x plus 7 power. And if you notice, by the way, I'm doing all of these problems using what we called method 2 in class. So there is another way to solve these problems, but just to save time, I kind of want to just be consistent and do it the same way every time. Put log on both sides and then move the exponents to the front. So we have 5x log 16 equals to x plus 7 log 64. Divide both sides by. Now, here's a funny thing. We have x's on both sides of the equation, so I can divide by log 16 on both sides, or I can divide by the log 64 on both sides. It really doesn't make a difference, but I'm choosing to divide by the log 16 because typically, if the smaller one, it will be easier. You'll have better numbers to work with than if you divide by the bigger one. So log 16 is smaller than log 64, so I figured if I divide by that, it'll make this number here a little bit easier to work with. And I think I'm right in saying that because log 64 divided by log 16 is 1.5. So again, we have a pretty normal equation, except for the fact that we have to multiply the 1.5. It's kind of like a backwards distributing, but it is distributing. Multiply the 1.5 with the x and 7. So we get 5x equal to 1.5 times x and 1.5 times 7, which is, I believe, 10.5. Oops. And so let's solve this. If you're cool, I'm going to erase this, kind of move this back up to the top. So 5x equal to 1.5x plus 10.5. Now I have x's on both sides, so my priority right now is to combine these x terms. I'm going to choose to move the 1.5x to the left side, combine those x's on the left side, get rid of it on the right, because then I'll have my x's on the left and my number 10.5 on the right. So it'll just be a pretty simple equation. Have 10.5 on the right, and then 5 minus 1.5 is 3.5 for the x. So now just divide by 3.5. We get x equal to, I believe it's 3. All right. So be careful with the decimals. The algebra is the same that you've been doing for a long, long time, but decimals might make it a little more tricky. So be careful about that. All right, we got 2 more exponential problems. So 243 to 0.2x power equals 81 to the x plus 5 power. So same steps as always. First step, put log in front of this. Step 2, move the exponents to the front. Step 3, divide by logs. Now, since 81 is smaller than 243, I'm going to choose to divide by the log 81. Leaves me with x plus 5 equal to 0.2x times 243 divided by, or the log 243 divided by log 81. So let me type that in real quick. Log 243 divided by log 81. 1.25. So people get a little bit confused here when you're multiplying these together. But if this was without decimals, imagine this was just like 4x times 3. I think most people would recognize 4x times 3 is just going to be 12x. Well, that's what we need to do here. It's just with decimals. So we need to do 0.2 times 1.25. So we get that as 0.25x if I just multiply those numbers together. equals x plus 5. And just like before, I'm going to move this to the top of the screen. So apologize to erase it. You guys have the really high-tech capability, though, of pausing the screen if you really care to see more of it. There we go. So now, just like the last problem, I'm going to move this x to the left side so that I can have my x's on the left and then have 5 on the right. But be careful, 0.25x minus 1x, you don't want to mess that up. Okay, the x's aren't going to cancel out. It's simply 0.25 minus 1, which gets us negative 0.75x. And at this point, we just need to divide by the negative 0.75 to get x equal to, it's a decimal, but it's negative 6.6 repeating, or negative 6.67 if you just want to round it off. But that's it for number 5. We got one more exponential to cover. Last exponential is 25 to the x power equals 125 to the x minus 2 power. Same steps as before, put the log on both sides. These problems are extremely repetitive. Move the exponents to the front. I always like to put in parentheses if I have like a multiple term thing to kind of remind me that they all kind of go together. Since 25 is smaller than 125, I'm going to choose to divide by the log 25. Leave me with x equal to x minus 2 times 1.5. And again, just like the problem we had two or three problems ago, we need to distribute this value. So we get 1.5x minus 3 on the right equal to x. And if you solve this, subtract by the 1.5x, that's what I would do. 1 minus 1.5 is negative 0.5. X equal to negative 3, and then divide by negative 0.5, we get x equal to 6. Apologize for going kind of quick. I do want to keep the videos short and just give you all the work, show you all the work, show you all the answers without making the video too terribly long. I already have videos that cover the explanation of this in detail. If you want to go watch that, the 7.5 video talks about exponential equations and logarithmic equations. I believe I made them 2 separate videos. If you want more explanation, go watch those. This is more or less just to kind of show you if you did your work right, show you where you might have made mistakes, and let you see the answer. Okay, but we're going to jump into number 7 now. So these are the logarithm problems. So these are a little different. We get log 4 x to the 5th equal to 20. So when we have logarithm problems, we don't do them anything like the exponential problems we just did. That's pretty much a brand new type of problem. There's no steps involved here. It's not like there's step 1, step 2, step 3 that we were following before. It's completely new. So what you have to do when you have logarithms is convert it into an exponential equation. So again, we've already covered this in previous videos, but the conversion of this logarithm into an exponential equation is this base 4 raised to this power 20 equals this part within the logarithm, which was x to the 5th power. So it's the exact same problem, but it's written now as an exponential equation. Now, 4 to the 20th power, normally I would try to type that in, but if you check on your calculator, 4 to the 20th power is a really, really big number because it's written in scientific notation in the calculator. So I'm not going to write that down. I'm going to focus on trying to get the x by itself. So notice we have x to the 5th power. So all I need to do is cancel out that exponent, that power of 5. And it's pretty simple to do. If you forget, if this was an x squared, we would cancel out x squared by square rooting it. And that will just leave you with x. If it was x to the 3rd, we would cancel it by cube rooting it. And that would just give us x. If it was x to the 4th, we would cancel it out by 4th root. And so same thing goes with all these other roots. What we need to do to cancel this out is take the 5th root of x to the 5th. But if I do that to the right side, I have to do it to this side as well. The 5th root of 4 to the 20th power. So on the right side, that's just going to cancel out, leave me with x. But now I need to type in the calculator the 5th root of 4 to the 20th. Now, let me actually go ahead and open my calculator to show you how to type that in, because I can see people getting a little bit stuck on that. So let it load. So to type that in, all right, you'd go to the math key. And the math key, if you look down, I believe it's the fifth option here, it says X root. If you select that, it'll let you choose which root to use. Now, of course, we're using the fifth root in our problem, so I'm going to type 5. So it'll do the fifth root. And then in here is where I'll type in my 4 to the 20th power. Because I don't want to obviously use that really long version of it that the calculator gave me. The calculator will work perfectly fine if I just type in the 4 to the 20th power. And I get my answer, 256. So let the calculator do the work. Logarithms can be pretty easy. Once you put them in as an equation, that equation's typically pretty short, but they could be more complicated, that's for sure. Let's look at number 8. Log base 3, x to the 6th equals 12. So just like before, I'm going to convert this into an exponential equation. We start with a base of 3, raise it to the 12th power, equal to the x to the 6th power. And just like it's pretty much the exact same thing as the last problem, if you want to, you can go ahead and write the 3 to the 12th power. That's not as big as the one before. You can write 3 to the 12th power out as 531,441. That's what 3 to the 12th power is. You can write it out like that if you want to. Doesn't make a difference. But we need to cancel out the 6. So just like we were explaining on the last problem, if I want to cancel out something to the 6th power, I would need to take the 6th root of it. So I'm going to take the 6th root of both sides. So that's going to leave me with just x. So you can type it in the calculator as the 6th root of that, or you can type it in as the 6th root of this. It's the same thing either way. Doesn't really matter to me. But when you do, you get 9 as the answer. So just be aware that when you have those exponents, you want to cancel those exponents out, okay? Especially on the next problem. So the next problem is log 4 x minus 6 to the 3rd equals 6. Same as before, convert this into an exponential equation. We have this as a base, 4 to the 6th power equals x minus 6 to the 3rd power. Now, if you want, you can go ahead and write 4 to the 6th as a number. 4 to the 6th power is 4,096. You don't have to, but it could help. It doesn't really matter. But here's a thing a lot of people mess up on. This power of 3 here, this exponent to the 3rd power, this really means x minus 6 times x minus 6 times x minus 6, multiplied out 3 times. We're not going to do that, but that's what it means. A lot of people think that they can just distribute this and call it x to the 3rd power minus whatever 6 to the 3rd power is. 6 to the 3rd power, not that I need it, but just out of curiosity, is 216. So they would write it like this, and that's wrong. You can't do that. So what are we going to do? Well, we're going to do the same thing we did on the last problem. I want to cancel out this exponent. So if I want to cancel out something that's raised to the 3rd power, what will I do? I'll take the cube root of that thing raised to the 3rd power. That way, the root and the exponent will cancel out and just leave me with the x minus 6. But of course, I need to do that to this side as well. So the 3rd root of 4,096 is 16. So we have the simple equation 16 equals x minus 6. If you add 6 to both sides, we get x equal to 22. So just be aware of that. Don't try to overthink the problem. Don't try to oversimplify. If you want to cancel out that power of 3, do it by using the 3rd root. Go away just like that. You don't have to worry about it anymore. All right, let's do number 9. Log 4. Oh, that was number 9. Hold on. Number 10. Log x minus log 10 equal to 14. So here's a different one. This one's unique because it's got 2 logs. So the first thing I need to do before I convert it into exponent form is to combine these logs into a single log. Now to do that, we need to remember the properties we talked about in the 7.4 properties of logs video. When you're subtracting logarithms, as we are here, you're not actually going to subtract the logs. You're going to take the values in them and divide them. So we're going to do x divided by 10. Now, what does that look like? X divided by 10 will just look like x divided by 10, x over 10. So that's what those logs look like when you combine them into a single logarithm. Now we're going to change it into exponent form. So remember the base here is 10, right? This is a log with a base 10. So that base will become the base of my equation. We'll have 10 to the 14th power equal to x over 10. Just rewriting it so I have a little more space. Now 10 to the 14th power is huge, just like 4 to the 20th power was huge earlier. I'm not going to write that all out. So let's just focus on canceling out this 10 on the right to get the x by itself. Now if I want to get the x by itself, I got to think, well, what's the opposite of dividing by 10? The opposite of dividing by 10 is multiplying by 10. So I'm going to do that to both sides. So now the x is by itself. And what does this say on the right? Most people, not most people, I guess, but sometimes people think it's 100 to the 14th power, and that's not true. Let me explain it to you this way. So 10 to the 14th power means 10 times 10 times 10 times 10, 14 times, right? I'm not going to write them all out, but it's 10 times 10 times 10, 14 times. Now, if you take those and you multiply it by another 10, as we are here, then what does it become? Well, it becomes 15 tens multiplied together. So our answer is simply 10 to the 15th power, which you can write out if you want to, but I'm just going to leave it as 10 to the 15th power since it's easier. Number 11, log x plus log 5 equals 2. So just like the last problem, we need to combine these logarithms into a single logarithm. But to do it on this, notice we have a plus sign. If you add logs, then you actually multiply the values in them. So x times 5 is going to be 5x. So remember that little trick? When you add logarithms, you're really multiplying those two numbers together. X times 5 makes 5x. Now we're going to convert it into exponential form. So just like the last problem, this is a base of 10. So we're going to use that 10 as the base. To the second power equals 5x. So 10 to the second power equals 5x. 10 to the second power is 100. So 100 equals 5x, and I believe you guys can figure out where this is going. Divide by 5, you get x equal to 20. All right, and one more problem, number 12. We have log x plus 9 equal to log 2x minus 7. Now think about this. This looks kind of weird because you have logs on both sides. So how's that going to work, you say? Well, it's really not that different, right? Notice that this log is equal to this log. So if these logs are the same base, doesn't that mean that this has to be equal to this as well? If the logs are equal to each other, then x plus 9 has to be the same thing as 2x minus 7. So essentially, we kind of can ignore the logs here. X plus 9 has to be the same thing as 2x minus 7. So I'm just going to set that up and solve the equation that way. So we end up with 9 equal to x minus 7. Adding 7 to both sides, we end up with x equal to 16. So there you go. That's going to do it for the video. I hope it helped a little bit. Again, this was primarily just meant for you to see the problems, see all the work, and make sure you got your answers right. And if you got them wrong, try to see what you did wrong. Quiz is tomorrow. So good luck. I'll see you guys then. Bye.